Hello everyone, welcome to chapter 8 of our Java tutorial, which is about methods. Well, in Java there are actually 3 types of methods, and all of these I'm going to address in this video, so this will be a rather long video. The first type of methods you know already, that's a constructor. They are used to generate new objects. So if you remember our examples from the previous chapters, we had a class point and we wanted to generate objects of that type. So here we would like to have an object P of type point, and that object we instantiate with a constructor. So you can always recognize this invocation of a constructor with this keyword new. And then there is the name of the constructor, which is always the same as the name of the class. And in the round brackets, you see the arguments handed over to the constructor. And these are usually the attribute values of your new object. So here I'm instantiating a new point object with coordinates 10 and 2. Well, the second type of methods we have used already. So those are class methods, meaning they belong to classes. For example, the method sqrt to compute the square root of a double number. And this is called class method because this method is actually, well, it belongs to the class math. So I'm basically addressing this class math. Dear class math, please compute the square root of 16. So that's how to read such a class method. You always have the class name dot name of the method, and then in the round brackets 16.0. And the outcome is then returned, and here I'm assigning that to this double variable d. So d is now 4. And now the third method is instance methods. So that's the third type of method. And they belong to objects. So here I'm not addressing a class, I'm not saying dear class math, but rather here on the left hand side of this dot I have an object. So in this case S is a string. It's an object of type string. Hello, for example. And what this method to uppercase does now is, well, it takes this string object and it converts all the characters to uppercase letters. So after that you will have hello just with uppercase characters. Hallo is the German word for hello. Okay, and also such instance methods, they return some output, and this output is then the new string with uppercase letters. And this is assigned here to this string variable sup. So class methods, I'm saying dear class. Instance methods, there I'm saying dear object. Dear string, please convert all your letters to capital letters and return the result to me as a new string. That's how you can interpret such methods. Well, here's an example. It's just the static void main method. So that's just the method that is executed whenever you start a program. And, well, it contains now methods of each type here in these 6 lines of code. So what am I doing here? First of all, you see I'm saying scanner s is equal to new scanner, and in round brackets, I'm saying system in. Well, so with that, basically, first of all, you see already it's a constructor because you have here the keyword new. And it also has this syntax that is required for calling constructors. So here you have class name, scanner, then the name of the object, s. And on the right-hand side of this equation system, there you have this equation symbol. You have the constructor call. And we always call the constructor with keyword new, then the name of the constructor, and in round brackets we put the arguments. And here this constructor of the class scanner requires just one input argument, which is basically telling the scanner what to scan. So here in our case, we put here system in, which is a reference to the keyboard of our computer. So the scanner now is created with the task to scan the keyboard, meaning whenever we type some button on our keyboard, then the scanner will be able to read this. So that's now this scanner object. So then what we do is next we use the system out print line method. So that's the method we used already in our very first example, in the hello world example. But here we don't say hello world, we say please enter a number. So this will be a string that will be printed to the console to ask the user to give some input. The user should now enter some number. So that's an instance method. We are kind of addressing this object system out. And this object we are asking, please write this string to the output. Yeah, so that's an instance number. System out is an object, and with println we ask this object to do something. Then what we do next is we have string input is equal s.next. It's again an instance method. It's taking this object s and asking this object s, please read the next input argument. As we used the constructor of the class scanner here, so what s is doing then, it's reading some input argument, and since we instantiated this scanner with system in, it will read the input from the keyboard. So what the user has typed will be read then with this method, and the outcome of this operation will then be assigned to this input variable of type string. Yeah, so dear scanner s, please read the next input argument. That's how we can understand this line of code. So now we have read a string from the keyboard. What we do next now is that we would like to convert this string to a double number, so that we can do some calculation with this. Maybe the user has typed 10.0, and this 10.0 is first of all read as a string, as a sequence of characters. But we would like to convert that to a number representation, to a double number. And for that, there is the method parseDouble in the class double. And this we can use now for this conversion. So we are addressing this class double, dear class double, please convert this string to a double number. And that is then returned, this double number, and we assign it here to this variable d of type double. Next, there's another call of a class method. sqrt, as I said already, that's a class method. It's defined in the class math. So I can now address this class math and say, dear class math, please compute the square root of the number I'm providing and return that. And this returned number we take then and assign here into this double variable r. Well, and finally what we do is just that we would like to report the outcome of this calculation to the console. And that I'm doing here with the system out println method. Again, it's just the concatenation of this string plus the value of r. And accordingly, what we get then is, well, that is just the result then. That is what we see. So now we have a nice little program which is asking the user for some input, which is then converting this input to a double number, which is then computing the square root of this double number, and which is then writing the outcome of this calculation to the console. And it's using class methods. In the case of double.parseNumber and mass.sqrt, it's using a constructor here to create this object of type scanner, and it's using instance methods, namely here system out println or this s.next, or again system out.println. So there I'm addressing an object, an instance, and asking this object, please do something. Okay, so that is then how you see this program executed in the console. So first of all, of course, we can compile this program with javac. Then we can run this program with the Java interpreter with Java. Then what is happening, of course, we are asked to enter a number. Then in this example, I typed 0.0625, return. And then what the program did, it computed the square root of this number, and the program then reported this number here to the console. So this is a very nice program now with input, calculation, output. Okay, so that was about how to use such methods. Instance methods, class methods, constructors. But next I'm going to discuss how to program, how to implement such methods. And when implementing a method, well, we first of all need to design this method. We need to decide, should we implement this method as an instance method or as a class method? Well, constructors of course also exist, but there this choice is quite clear. When we want to create new objects of a certain type, then we implement constructors. But if we want to do some calculation, for example, then we need to choose an instance or class method as the underlying construct. And usually this choice is up to us. We can decide freely. However, our decision will influence how this method will be used then later. And then I'm showing here on a small example. So class methods are associated to classes. What I can do, for example, I can think of a method to compute distances between 2 points. So you see already this is point P instantiated with the constructor of the class point with coordinates 10 and 2. And I have a second point, point Q, which I'm also instantiating here with the constructor of the class point, but with coordinates 14 and 5. And now I'm using a class method defined in the class point. So basically I'm asking the class point, please compute the distance between P and Q. And the result is then a double number which is returned, and I'm using this output then to instantiate this variable d. With that I have then computed the distance between these points. Of course, provided that the method distance is implemented as a class method in the class point. Then this will work. Okay, then instance methods, that was the third type of methods that I introduced. Yeah? First type was constructors, second type class methods, third type instance methods. So here, this is how I would use an instance method basically. Again, I would create these 2 point objects, P and Q. That's the same as before. But now that I would like to compute the distance between these 2 points, I would need to ask this point P. P, please compute the distance from U to this other point Q. So basically here, on the left-hand side of this dot symbol, you have an object, an instance, P. And this object I'm asking, please compute the distance to this second object Q. So, and of course, because this P is already here, you don't need to provide this here as an argument to the method, because the method is called for P. And we have already also knowledge of the attributes of P. So the x coordinate and the y coordinate, if we do this call. All what we need is then this second point object Q to compute the distance. So that's basically how you use a class method distance and how you use an instance method distance. And next I'm showing how to implement these two methods. First of all, well, what do you think? Which of these methods called is more intuitive? That's maybe a question that you should answer yourself. Yeah, so what do you think is more intuitive? But I would like to point out that this second approach is more common, that you ask some point P, please compute your distance to some other point Q. So this second approach is more common. Well, and therefore I'm choosing that approach first, and I'm showing you how to implement such a method, how to program it. This is again how to call such a method. That could be done in the public static void main method, as we just did. But this is now another class and accordingly a different file, namely the file point.java. And in this class, well, the first 5 or 6 lines of code you have seen already. That is just the definition of the two attributes x and y and the constructor which we use to instantiate new objects of this type. But now, after that, we have our distance method. The distance method implemented as an instance method. Well, and what we do here is basically that, first of all, we compute what we call dx usually. Yeah? So that's the delta x, maybe also p2.x minus x. So that is the x-coordinate of point p2 minus the x-coordinate of the point for which I'm calling this method. Yeah, so here in my example above, that would be point P, and P2 would be point Q. So that is the point I'm passing over to this method, and here this point is referred to as P2. And if I'm accessing x and y, that is referring to the attribute values of the point for which I'm calling this method, namely P. Well, and after these two first lines of code here, I have computed the delta x and the delta y, and now I just need to compute the square of this delta x and the square of the delta y, and of the sum of both I need to compute the square root. So you see these round brackets, and the outcome of this computation is then returned. Yeah? So this keyword return, it is always used to return the calculation of some method. So, and this is then the instance method that we provide here in this class point, and that can be used then also outside this class, for example in the public static void main method, as you've seen in the previous example. Okay, just a few things to remember. The first line here, that is basically the method header. That is already quite informative. It's saying here double. So that means here this method is returning a double number. Yeah, I mean, of course, here I'm returning a double number. I'm computing the square root of this delta x squared plus delta y squared. But here already in this method head, I need to say already what type I'm returning. And that is basically this double here. It's the data type of the returned value. Then next we have the name of the method, its distance. Of course, I'm using this name also when calling the method. And then in these round brackets, I have the method arguments, so values that I would like to hand over to this method. That is not different compared to constructor calls. There we also have the arguments of the constructor in round brackets, and here it's the same also in this example of this instance method. Well, as I said already, in the round brackets, you have the method arguments, and of course the method expects as input a variable of type point, and this is here internally within this method. This variable is called p2. That doesn't mean that you need to call such a method here with p2 in the round brackets. Of course, this is valid too. Yeah? So here we put q in these round brackets. But if we take then this argument for this computation, so internally this point is called p2. Well, and what is important, this method call, this invocation of the method is only possible because q here and this p2 are of the same type. So only because I'm providing here this method with a variable that is of the required type, namely point, only because of that this method call is valid and successful. Okay. The method has the return value of type double, and therefore this assignment here is valid. Yeah, so this assignment actually works. I have a double variable d here, which I can assign here, or to which I can assign the output of my method distance. This works only because this method returns a double value. Then I would like to say a little bit more about this return keyword here. So after this return comes the argument that will be returned. So this is the outcome of this computation. Yes, and this is then returned. So when we call this method here, we will basically take the returned value, and this is then assigned to the left-hand side of this assignment, namely to variable d. What is also important, that as soon as this return is reached, the method will be terminated. Yeah, so every line of code after this return will not be executed anymore. So return is also kind of indicating the end of the method. If there's anything coming after that, that will not be executed. Okay. And well, this I already explained. p2.x, that is the x-coordinate of my method argument, the point p2 that I'm receiving here, and x is simply the attribute of the point for which the method is called. So in our example here, that is actually p. What I would like to point out is also, to make this a little bit more readable, we can also say this dot x. So instead of just saying x, we can say this dot x. And that is making clear, yes, I would like to have the x-coordinate of this point, namely the point for which this method is called. Yeah, so that is basically, if I'm calling the method for point p, then this is referring to p. And p2 is of course referring to the point that I'm taking here within these round brackets. So that's the method argument that is handed over here to the method, q in our example. Okay, very nice. Our first example of an instance method that we have implemented, that we have programmed ourselves. We can also add such methods to our UML diagrams. Yeah, just to remind you, UML diagrams are nice to visualize a model, a conceptual model behind our program. So, and this is showing, okay, there is this class point, it has two attributes, x and y, both are of type double, and then there is also this instance method, distance, which is requiring a point object and which is returning a double value. That's how I would visualize this in UML. Now, What else could we do? We could also say, okay, instead of computing a distance to another point, we would like to translate our point. Yeah? So we would like to move it by some dx and some dy. So that's the example here, translate. So basically, we have some point P, which has been instantiated with a constructor, and now we would like to move this point, for example, by 1 unit in x direction. So we would call P.translate 1, 0. 1 for the x-coordinate, 0 for the y-coordinate. That would translate t a little bit in that x direction. And this translate operation I can also implement as an instance method. Of course, I would call this method then for some point, maybe P.translate. Well, that's of course because it's an instance method. I always need to say for which point this instance method I'm calling. And then I have here for the translate operation, I need two arguments, namely dx and dy. That's the amount I'm translating the point in x direction and y direction. And internally within this method, all I'm doing is that I'm taking the x-coordinate of my point and I'm adding dx to it. And the outcome is then my new x. Yeah, so again, such an assignment needs to be read from right to left. I'm evaluating this right-hand side first. The outcome is then assigned to my x variable, and that is then the new x-coordinate of the point for which I have called this method translate. And similarly, I can do the same with the y-coordinate. I take the old y-coordinate y, I'm adding dy to it. The outcome is then assigned to this attribute y, and that is then the new y-coordinate. So you see, I'm doing here something with the method to change the values of x and y. However, I'm not returning anything. I have just changed the attribute values of this point. But it was not about computing, I don't know, a distance that needs to be returned now. And therefore, if a method doesn't return anything, this return type here is void. Yeah, so you see, for the distance method, this return type was double, and here it is void, meaning this method does not return anything. That doesn't mean that this method doesn't do anything. Of course, it does something. Namely, it changes the attribute values of the attributes x and y. But that's all. It doesn't return anything that I could fetch and use for my further calculations. Well, what else? Here we have an example of how to use this translate method. It could be 3 lines of code within the public static void main method. Yeah. And here what I'm doing is just that I'm creating a new point object with coordinates 10 and 2. I'm translating this point object then 2 units in x direction, 1 unit in y direction, calling this instance method for the point P, the instance method translate. But you see here, I'm not taking this outcome and assign it to a variable. Yeah, I'm not saying a is equal to p translate 2, 1, because actually this method doesn't return anything. But it has changed now the coordinates of point P. So now if I print, for example, the x-coordinate of point P to the console, what I get is then not 10 anymore, but it's 12, because it has translated P by 2 units in x direction. And that's what we see here. I'm compiling the program, I'm running the program with Java test, and I'm getting this output, x is equal 12.0. Nice. That way I can translate points. Okay, so much about instance methods. This is the slide you have seen earlier, giving the overview of the different types of methods, class methods, instance methods. Now I would like to show that the distance method I could just as well implement as a class method. Yeah, so this was the approach you've just seen. Here I'm asking this point P to compute the distance to some other point Q. But what I could also do is that I'm implementing distance as a class method within my class point. And here I would ask the class point, please compute the distance between these 2 points that I'm providing here. And that is what I show next, how to implement such a class method. Okay, here you can see already, well, this is still the instance method, but if I change now the instance method and implement it instead as a class method, you see there's not such a big difference. Of course, you see already here the difference in how I'm calling the method. Yeah, so for the instance method, I'm asking the point P to compute the distance to Q. For the class method, here I'm asking the class point to compute the distance between P and Q. Well, but here, when we implement the method, there's also a difference. First of all, the return type is double. That's the same in both cases, double. The name of the method is also the same, distance. Yeah. Now, here, I'm calling this method for some point. Therefore, in these round brackets, I needed to provide only one other point. But here I'm calling this method for a class, namely for class point. And therefore, in the round brackets, I need to provide 2 arguments, namely, let's call it P1 and P2, and both of them are of type point. So what is also important now, the difference that you see here. Here we had just double distance, but here we have static double distance. And this keyword static, that is just to indicate this is a class method. So static is always providing the information that this is a class method. When calling this method, you need to provide the class name and then dot the method name. Well, what else are we doing then? Well, we are computing the dx again. Of course, we need to compute then p2.x minus p1.x. And for dy, it's very similar. We need to compute p2.y minus p1.y. And then we compute the square root of the squared x coordinates plus the squared y coordinates. And that is then all. So the main difference is then that here we have the static indicating it's a class method. Here in the round brackets you need to remind yourself that, okay, I need to provide both points here because I'm calling the method just with the class name, so that we have access to 2 points. Actually, we need 2 point objects as arguments. And the static is indicating class methods. So, just one important note, within class methods, you cannot use this. Yeah? In the instance method, this is referring to the instance, the object, for which you are calling the method. But for class methods, there is no such object. You're not calling the method for an instance. And therefore, within a class method, within a static method, you cannot use this. You will get a compiler error. Well, here, the same we can do with the translate method. Just as we have seen the translate method earlier, we defined it as an instance method, but also here we can define this translate method as a class method. So, what do we need then as method arguments? Well, here we need first of all a point to translate, and then we need the 2 coordinates, the x coordinate and or let's say the x value and the y value by which we want to translate the point. Well, and then we can implement the translate method again as a class method, namely static keyword is required. Void, that's still the same. This method should not return anything. It should just change the attribute values of the point p. The point p is then our first method argument, and the second and third method argument are dx and dy. Well, that's it for the moment. In UML, we can also visualize class methods, and you see here this distance method in UML. There we are requiring two point objects as input arguments. We are returning a double value, and to indicate that it's a class method, I have this underline here. So the underline for a method, it shows that this method is a static method, a class method. Well, to summarize, we have seen these three method types, constructors, that is used to create new objects of a certain type, in this case a new point object p with coordinates 10 and 2. Then we have class methods. These are assigned to classes. So for example, I can address a class math and ask this class, please use your method sqrt to compute the square root of 16. And the output is then, here in my example, assigned in this double variable d. And then we have instance methods. These are assigned to objects. So here, for example, I'm creating a string object s with this string hello, and now I'm calling this instance method for this object s. So I'm asking, dear s, please convert all your letters to uppercase. And the output is then a new string which we assign here to sup. So, constructors you always need, if you have your own classes, you need your own constructors to generate objects of these classes. Class methods, I would recommend to use class methods only for computations and operations which cannot be assigned to an object. Yeah, so translating a point is of course something that has to do something with this one point. So I would rather compute this or implement this as an instance method. And instance methods, I would say, yeah, by default, whenever you do something involving at least one object, then you should consider whether you could implement this as an instance method. That's it for chapter 8 of the tutorial, and in the next chapter we are going to discuss if statements and branches. Thank you very much and bye-bye.